Hello everyone. We will now begin working on the solutions of project number 3, which is meant to be a study guide or a preparation for the upcoming test 3. I will begin with question number 1, which is a question on verifying identities. Now, there's no set way of going about verifying identities. Each one can follow different ways. However, for most of these verifications, you have to apply some of the basic identities that you learned previously and make the right-hand side expression equal to the left-hand side expression or vice versa. All right. However, it is very important that you show every step of the verification process. Otherwise, the proof will not be valid. All right. So I will go about my way. However, you can follow a different way as long as it is a valid way and you are applying the basic principles, the basic identities to simplify one side, the more complicated side of the identity to match with the other side. You will still be considered correct. However, show all the steps, how you are proceeding to get to the final step. Now, part A of the question has this expression, cos of theta times secant of theta divided by cot of theta equals tan of theta. So on the left hand side, we have cos theta times secant theta divided by cot theta, and on the right hand side, we have tan of theta. Therefore, supposedly, the right hand side and the left hand side should be equal to each other. Now, the general rule is start with the more complicated expression in the identity and try to reduce it or simplify it to match the other side. So here the more complicated expression, of course, is cos theta times secant theta divided by cot of theta. The way I'm going to go about it is work with the left-hand side. So we have cos theta, and I'm going to write the secant theta as 1 divided by cos of theta, because secant theta is the reciprocal of cosine. I will be applying the reciprocal identity here. Let me write that down. Reciprocal identity is being applied in this step to rewrite secant of theta as 1 divided by cos of theta, correct? And then divided by, we have cot of theta in the denominator. I'm going to just write it as is. And that should be equal to tan of theta. Now in the next step, let's simplify the numerator of the left-hand side expression. Cos of theta and cos of theta will divide, and we will be left with 1 divided by cot of theta on the left-hand side. On the right-hand side, we have tan of theta, and 1 divided by cot of theta is tan of theta, correct? By the reciprocal identity, 1 divided by cot of theta equals tan of theta by the basic reciprocal identity that we learnt before. So we can write that as tan of theta equals tan of theta, and we just proved that the expression on the left-hand side of the identity matches with what we have on the right-hand side of the identity. Right? So this was a fairly simple verification, but over here in the step before, let me specify that we use the reciprocal identity to convert 1 divided by cot of theta to tan of theta. We will now work on the identity in part B of the question. It says cosecant squared t divided by cot of t equals cosecant t times secant t. Now, as I said before, the identities can be verified using many different ways. However, as long as you show all your steps and the steps are all valid and logical and lead to the final verification where the right-hand side equals the left-hand side expression, you will be considered correct. All right. Now, I'm going to do it my way, and I will work with the left-hand side of the expression and prove that this can be simplified and written as cosecant t times secant t, which is the expression on the right-hand side. So again, please work step by step very clearly so that it's easy to follow, and also mention the basic identities that you are applying to get from one step to the next step. So cosecant squared t divided by cot of t can be written as cosecant squared t multiplied by 1 divided by cot t, correct? So all I did was I separated the cot of t and wrote it as 1 divided by cot t. Now by the reciprocal identity, we know that 1 divided by cot t is equal to tan of t. So in the next step, I will replace 1 divided by cot of t with tan of t. So which identity did I use in order to convert 1 over cot t by tan t? It was the reciprocal identity. It's best to write it out. All right, it was the reciprocal identity. Now, tan of t can be replaced by sine over cos. Recall, we learned one of the basic identities, which was known as the quotient identity, where tan was equal to sine over cos. So in the next step, I will replace tan of t with sine over cos using the quotient identity. Let me write that down. It's quotient identity that I'm applying. Cosecant squared t has still to be written as is. Do not get rid of it, because then it will not show the logical flow of the verification process. I'm going to replace tan of t with sine t over cos t. So now I'm going to extend the division line of the fraction, because cosecant squared t times sine t can be put under cos of t. Now in the next step, I will work with just the numerator of this fractional expression, and I will replace cosecant squared t with 1 divided by sine squared t using the reciprocal identity. At this point, I will not touch the denominator, which is cos t, but I still have to write it down, all right? Because I will write it as cos t in the denominator, but in the numerator I will replace cosecant squared t with 1 divided by sine squared t. Let me just space it out a little bit here. So I have cos t in the denominator. In the numerator I will have 1 divided by sine squared t. I just use the reciprocal identity again to replace cosecant squared with 1 divided by sine squared t. All right, and then over here I have sine t. And what happens here? Sine t and sine squared t can be simplified and written as 1 divided by sine of t. So 1 divided by sine squared t times sine t gives us 1 divided by sine t over cos t. So I have simplified the numerator of this fractional expression and written it as 1 divided by sine t over cos t. And now I'm going to perform the division here. So we have a fraction in the numerator and cos t in the denominator. In order to simplify this, we can write it as 1 divided by sine t. Remember how we perform a fractional division? We change the division to a multiplication and we flip the denominator. What was cos t in the denominator will now become 1 divided by cos t, correct? So now we have 1 divided by sine t times 1 divided by cos t. 1 divided by sine t by the reciprocal identity is equal to cosecant t, and 1 divided by cos t is the same as secant t. It's reciprocal. Let's write that down. We use the reciprocal identity to get to this step. And now we've just shown that the left-hand side of the expression can be written as cosecant t times secant t which is the exact expression we have in the initial identity given to us. All right, so cosecant squared t divided by cot of t equals cosecant t times secant t has just been verified. All right. We will now work with the identity in part C, which is sin t over tan t plus cos t over cot t equals sin t plus cos t. Now, like I always say, an identity can be verified in many different ways. However, I will proceed in verifying this by combining the terms on the left-hand side. And once we add the two terms, we should be able to simplify it and get to the expression on the right-hand side, which is sin t plus cos t. So on the left-hand side, the common denominator is tan t cot t. Let's write that down. So in the first step, I'm finding the common denominator, which is tan t cot t. And then in the numerator, it'll be sin t cot t, sin t times cot t plus cos t times tan of t. So in the denominator, we have tan t multiplied by cot t. They are reciprocals of each other. We can write it as sin t cot t plus cos t tan t in the numerator divided by tan t times, now cot t can be written as 1 divided by tan of t. Therefore, tan t and tan t would divide and we would be left with 1 in the denominator. Now, we just have the numerator to work with. We have already reduced the denominator to a 1. We need not show the denominator anymore. So we have sin t cot t plus cos t tan of t. Now at this point, we will be using the quotient identities to write cot t as cos over sine, correct? So let's write that. So we have sin t. Cot t is going to be replaced by cos t divided by sin t. And then for the other term, we have cos t multiplied by tan t. I will write tan t as sine over cos, correct? So sine t over cos t, and then what do we have? Sine t and sine t divides. So we are left with cos t for the first term, cos of t, and for the second term, cos t and cos t divide, and we are left with 1 times sine t, which is plus sine t. And that is exactly what the right-hand side of the identity is. They have sine t plus cos t, which is the same as cos t plus sine t, correct? Let's take on the identity in part D now. The expression is tan t plus cos t divided by 1 plus sine t equals secant t. I'm going to begin by tackling the left-hand side of the identity. I'm going to try to simplify this by combining the terms. However, I'm going to first rewrite tan t in terms of sine and cos using the quotient identity. Using the quotient identity, tan can be written as sine t over cos t, and then we have for the second term cos t divided by 1 plus sine t. We have to take the common denominator, which would be cos t times 1 plus sine t. Let's surround 1 plus sine t within brackets because that's a single expression. All right, so we are going to write it as cos t times 1 plus sine t, which is the common denominator of the two terms. And then for the numerator, the first term will now become sine t times 1 plus sine t, and then plus cos t multiplied by cos t. Because we have the common denominator, we have to adjust the numerators accordingly. All right. So now let's multiply sine t with 1 plus sine t. In other words, we will be distributing sine t to the terms within the brackets. we'll end up with sine t plus sine squared t. And then we have on the other side of the plus sign cos squared t. Cos t multiplied by cos t gives us cos squared t. And then in the denominator, we have cos t times 1 plus sine t within brackets. Now, using the Pythagorean identity, sine squared t plus cos squared t equals 1, correct? This entire expression can be replaced by 1. This is equal to 1. Therefore, we end up with sine t plus 1. If you replace sine squared t plus cos squared t with 1, then you end up with sine t plus 1, and then in the denominator we have cos t times 1 plus sine t. Now in the numerator we have sine t plus 1, which can be rewritten as 1 plus sine t, correct? Sine t plus 1 is the same as writing 1 plus sine t. And then we have cos t times 1 plus sine t in the denominator. Let's divide 1 plus sine t and 1 plus sine t. So we end up with 1 divided by cos t, which is equal to secant of t. And that is exactly what we have on the right-hand side of the identity. So now we have verified the given identity here, which is tan t plus cos t divided by 1 plus sine t equals secant t. So it's very important to show all the steps that lead to the final verification, right?